Hi everybody. A few weeks ago I was watching a thing on the Apollo space program, and it made a point to bring up how that we essentially sent men to the moon using nothing more than slide rules. The calculators that we had back then were basically, they took up entire rooms, and you couldn't rely on them to do quick calculations. And it was actually much more efficient for people to use these slide rules to do the calculations that they needed. And that piqued my interest because I wanted to know how essentially just a sliding piece of paper could send men to the moon accurately with the huge and very small numbers that they had to compute. So I made this one up on my laser cutter. It's just a acrylic, and I glued some scales to both ends and just made a way for it to be encapsulated in there and have a cursor that slides back and forth. But when I started looking at YouTube videos on how to use them, I didn't ever really see a good tutorial about the how multiplication, division, and all these are done. There's a lot of good literature out there, but I wanted just a dumb guy's way to just watch and explicitly show me how these things are done. And that just isn't out there. So hopefully that's what we can do here. The simplest operation we could do is probably just multiply by 1, but that's not very fun because we essentially aren't doing anything. So the simplest operation we can do where we're doing maths is to multiply by 2. And I'll show you how to do that with this slide rule. Almost all the operations we're going to do is going to use either the C, D, or DI scales. The rest of these will be either sines, cubes, squares, logarithmic stuff that you don't really run into every day. So the main principle behind this is that you'll see that this is on a logarithmic scale. And you can see that the distance between the 1 and the 2 is pretty large. And then the 2 and the 3 is smaller, and it keeps getting smaller until you see over here the 9 and the 10 pretty small. And the other thing you'll notice is that both of the C and D scales are actually all the same size, going all the way across. And that's because what this does, all multiplication is on this, is log x times log y will give you the log of x and y. So in other words, let's do a problem. Let's multiply by 2. And this is, I haven't seen anyone use this method, but I like to call it what would be a z method. And it's because we're going to make a z motion. And it's not really a z motion. I guess it would be like a z on its side that's been mirrored, but it's almost such a bad name that it sticks in my mind pretty well. So we're going to index the number 1 on the C scale to the number that we want to multiply, or the number that is being multiplied. It doesn't really matter since multiplication is commutative. We can do it either way. And we're going to index that to 2, since we're multiplying a 2. And let's multiply by 3. So we'll come up here, and then to complete that z motion, we'll come back down and see that's 6. So again, we're going to make a z motion, 1, 2, cross, like on a z, and come back down. And indeed you'll see that actually all of the numbers have been multiplied by 2. So 2 times 2 is 4. 3 times 2 is 6. 3.5 times 2 is 7. And you can go all the way across and see that 5 times 2 is 10. Now, some of you will think, what happens to all of these numbers? Can we just not multiply by 10 by 2? And that's, if you really think about it, we only got to 10 because everything after 10 has to have 2 digits. And so that couldn't be represented out here. We only have essentially 1 digit. So what we do in that case is index, let's say we want to multiply 6 by 2, and we can either, we'll just use our right index here, and we'll set that to 6. So now it's set by 6, and just like we did before, we're going to cross up back into the C scale and find our 2, because we're multiplying 6 by 2. And then we're going to complete that Z motion and come down here. And what is kind of weird to the uninitiated is that we have 1.2. And this is the first problem that we have that you're going to run into with slide scales, is that a slide scale doesn't keep track of the decimal point for you. It takes a little bit of work on your side to place the decimal point where it's supposed to be. So we've accepted the fact that we're having to keep track of our own decimal points. The next question I ran into was, how are we going to multiply by numbers smaller than 1? If we look at it, it starts at 1, goes up to 10. A lot of problems that we run into will be to multiply something by, let's say, 0.5. And that falls back on the rule that we're keeping track of our own decimal points. So in order to multiply by 0.5, we're actually going to multiply by 5 and then move the decimal point as we see fit. So in order to do that, let's do an example. Let's set our right index to 5 since it's over the half point of our ruler. And now we'll do our Z motion. So we're going from our right to the number that we're multiplying by up to the number that was being multiplied, and you'll see that it is at 4. And indeed we can go all the way down. 4 divided by, or multiplied by 0.5 is 2. You notice how I sort of just slipped up and said that we're dividing by 2, and it's one thing that is kind of nice about the slide rule is that it sort of massages your brain into looking at math differently than we usually look at it when we use our calculators, where all of the operations are different and distinct, when in reality all of the operations are pretty much the same. If you understand math enough, you know that addition and subtraction are really the same thing, that subtraction is really just adding negative numbers. And in much the same way, division and multiplications are just two sides of the same coin. But how would we do proper division? So let's say that, let's take some larger numbers, and we're going to, let's say, divide, let's say 64 by 8, and that'll give us some whole numbers, so we aren't going too far. And that's where we're going to actually start using a different scale. You'll see that we have DI, which is just the D scale, but inverted. So you'll see that instead of starting at 1, it starts at 10, and gradually gets bigger as we go over, and we'll eventually reach 1, where the D scale terminates. So what I do for division is I start with a number that's being divided. So what did we say? We were going to do 64. So we're going to, we could try, we'll have to keep in mind, let's see if we can get you in a little closer. And this is kind of where a cursor comes into play, and I know I was kind of being lazy before. So we're going to set our, let's find 64, and we're keeping in mind that this is inverted, so we aren't like up here where it'd be getting bigger. It's actually going to get bigger, so we're going to find 6, and then go 1, 2, 3, and 4. And we're only using the cursor just because it makes it a little bit easier to line up our slide. And then once we get this lined up, you notice I just kind of put my slides, actually, since this is homemade, this was as thin as my laser could cut. And so I'm actually just indexing both of these on the left side of this line. So we're at 64 and we've indexed. And now we're going to do the same thing that we're used to doing. Oh, and I just messed up our index. So we're going to do the same motion. So now that it's indexed, we have our beginning, it's index. We're going to find number 8. And shoot, we've run off the scale. So we'll bring it all the way over and index our right side. And that's going to be close enough. So now we can move our cursor. Again, we have 64, which is where we've indexed, and now we need to find the number 8. So let's slide our cursor over to the number 8, and then we'll complete that Z motion and come down and see that the number 8 is our answer. And indeed, 8 times 8 is 64. And just because division is a little bit harder or more tricky than multiplication, let's do another one. So let's actually, so we can start wrapping our head around the decimal placement, why don't we take 18 and divide that by, let's make a nice number, let's divide it by 3. So let's set this right index to 1.8. And again, we're doing this because 18 is bigger than 10, so we won't be able to reach 18. So 1.8. And let's start sliding our cursor. And let's find 3. And then we're going to complete the Z motion that we introduced back with multiplication. Look down here, and we see that we have the number 6. And like the last problem, 3 times 6 is indeed 18, or in this case 1.8, and we have to move the decimal over ourselves to 18. So after a bunch of experience with this, I looked up some practice problems, and it turns out that there's actually a slide rule, calculation, international competition, I guess. And they actually have a PDF of a bunch of problems that you can do, and it's meant for a competition, but we can just do it to get more familiar with our slide rule. And so I sort of cherry picked some of them that are more representative of stuff that you'll run into every day, and so we can just walk through some of these. So let's try 42.1, and we'll multiply that by 7.65. So the first thing that we're going to do is sort of evaluate how we're going to move our cursor. So this is the lower of the two, so let's try to find, and we'll sort of zoom in a little. So we'll set our left index to 42.1. So here's our left index at 4, 4.1, 4.2, and then just right off to the right side of that will be 42.1. So now, if we want to multiply that by the 762, shoot, we've ran off the side, and taking note of that, it's because we're going to add a digit. We're going to actually move the decimal point And now we know that our answer is going to actually be a 3-digit answer. So it's important to take note of little clues that our slide rule gives us like that. And because obviously multiplication is commutative, we can do either side. It doesn't matter which side is being multiplied by which. So why don't we now set this to 7, 6, 5. So let's find the 7. We'll go to 7.5, 7.6, and then right down the middle between 7.6 and 7.7 will be 7.65. Okay, and now we need to find what will essentially be, well, what we'll call 4.21. So let's start using our cursor. So we're at 4, find 4.1, 4.2, and then just right off to the right hand side of that, and we'll call that good for 4.21. And so we'll start doing our Z motion. Again, we have our top of our Z, we find 7.65, cross back up to our C slide, find 4.21, and come down to our answer. And so our answer looks to be 3, 3, 1, 3, 2, and there's one little tick mark which will be representative of 3, 2, 2. And so we know our significant digits. And like I said before, since we ran off the right side of our slide rule, we know that we had to move a decimal point. And so where our decimal point was, and we'll move it to the right, we know that our answer is 3220. And if we want to confirm, we can do that. 42.1 times 7.65, and indeed, to a surprising amount of accuracy, for just a slide rule, 322065, and we got 3220, which is actually really close. Okay, so let's do some division that's not so trivial, which was the second problem. And we'll take 68.2 and divide that by 5, or actually 0.575. So we'll sort of evaluate this. Why don't we just set it up like we normally do using the D inverted scale. And when I'm using the D inverted scale, I usually use my cursor and then line up the slide with my cursor, just because it's a little offset, makes it a little bit more accurate. So let's take the thing that is being divided, 68.2. And again, since we are on this inverted scale, we're going to be moving bigger this way, so we don't want to make the mistake of trying to find 68 on this side. We're going to go 6, 6.5, 6, 6, 6, 7, 6, 8.5, and then we'll set our cursor just to the right of that one, to the left of that line, and then we are dividing by 5, or 0.575, and so like we said before, we're going to find the 5 on our C scale. So let's start moving our cursor over. And so we're in the 5. Here's 5.5, 5, 6, 5, 7. So we need to split that. 5, 7, 5. So let's come back down to our D inverted scale, which is along this. So we have 1, 1.1, and each one of these represents another tick between 1.1 and 1.2. So we're at 1.1, 1.15, and then we have 3 dots, and so it'll be on the 4th line here, which will be 118. So if we think about this, if we were doing multiplication, if we were multiplying the 68.2 by 0.57, it would get smaller. But because we're dividing by a number that's less than 1, it's going to get bigger. So we know that our number can't be 11.8. So we know that the next possible answer is going to be 118. Now the one way we can check ourselves is by writing these out in scientific notation. So we just write it out as we did before, 68.2, and to finish off the scientific notation for this term would be times 10 to the 0. That's because anything raised to the 0 power actually becomes a 1, and then we know that 68.2 times 1 is going to be the same answer. And we were dividing that by 0.575, so we'll move the decimal place 1 to the right, and that's going to become 5.75. And because we did have to move the decimal place on this one, it'll be times 10 to the negative 1. And we've already evaluated this part, so we can sort of disregard this. And when we divide exponents, we're actually just doing subtraction. So this, for the answer, which we got was 11.8 technically, it would be times 10 to the, we had 0 minus a minus 1. And because we are subtracting a negative, we know that we are adding a positive. And so this now becomes times 10 to the 1. And then we can simplify this further as 118. And so now we know for certain where this decimal place went. So one last problem that was on the, well, there were a lot of problems on the test, but one last thing that most people will actually run into in their daily lives will be squaring and square rooting. And this is also done pretty easily on slide rules, and that will be with our A scale. And you go between either the C or D, since they're the same. Most people will use the D because it doesn't move around on you. And you'll start with the number that you want, or the number that you have, and then you'll square that by looking at where this cursor lines up with it on the A scale. So the problem that was on the test was 615 squared. So let's sort of zoom in if we can, so we can give you a good look. Okay, so we'll bring the cursor over, we'll find our 6. Here's 6-1. Since mine is homemade, it's not a very accurate, so we might not be super accurate in our answer, but we'll give you a good look. So 615 should be about right there, and then this is our A scale, so it's the second one up. So let's look. We know that we're at 3, and here's 3, 5, 6, 7. You can just barely see the 5 poking out, so it's just a little bit off to the right. We'll call it maybe 3, 7. Let's call it 377. So we know that these are our significant digits to the answer. And because this is essentially 615 multiplied by another 615, we know that for sure it's going to be larger than a 3-digit answer. So we know that this is the first 3 digits. The only question is, how far out are we going to go? one rule of thumb that I follow is you add up the total amount of places you have, which would lead us to an answer of 377, 000, or 377,000. So let's find our number 615, and we are going to square that. And so our total number is our actual number 378,225. So with the slide rule, we've actually gotten really close. If we want to see just how close we've gotten, we can find a percentage just by dividing that into this. So we'll say 377,000. We'll divide that by 378,225, and we'll have percent. You see that we're well within even 1%. We're only about 0.5% off, and I think that's pretty remarkable. So anyway, guys, I think these things are really fun. For about the past week, I've been sitting in my office doing math tests of different websites with my slide rule, seeing how accurate I can get, and I'm actually doing pretty well. If this interests you at all, I recommend first going to the International Slide Rule Championship. It has a practice test that you can do, and also they have a PDF that shows you how to do some. It also gives an explanation on multiplication, division, but it also shows a lot of the other stuff you can do, like logs, sines, cosines, tangents. So it's a great website. There's another website that has a bunch of different slide scales that show you how to create your own. Also on eBay, these are running about like $20. I think it's I think it's super worth it. If you're a nerd like me that thinks these things are really cool, physical computing like this, it's totally worth $20 because I've been using this for, like I said, about a week to do practice tests on my own. So if you liked what you see, nah, I'm just kidding. I'm not going to do a like, rate, and subscribe. You can do whatever you want. We'll see you in the next video.